This is a word problem. It's 2.4 practice C, number 25. So I need to write a linear model for the U.S. population from 1950 to 1960. And it gives me a little bit of data. It says in 1950, the population was 152,271,417. That's pretty precise. And in 1960, the population was 180,671,158. Now they say assume that a 5% variation of the actual from the forecast is acceptable. I'll write that down over here, but I kind of have a feeling that that's really not all that important, because what they're asking me to do in problem number 25 is find a linear model for the U.S. population from 1950 to 1960. And they say, let t equals 0 be 1950. And that, again, also may or may not be important. So when I'm looking at something like this, I can look at it in a number of ways. I think that my approach would be this. I would make a graph. Now I know I'm dealing with time and population, so I'm really going to be concerned with quadrant number 1. I'm not going to be concerned with quadrants 2, 3, and 4, because they all involve negatives, and I know there are no negative time or population. But if I drew the graph and, and it was a regular x-y axis, that would work out as well. And what they've told me here is that t equals 0. So I know that time is going to be on my x-axis, because whenever I have a situation with time, almost always it's on the x-axis. And my y-axis is going to be population. And they said t equals 0, so t is time. T equals 0 right here is the same thing as 1950. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means this is going to be 1960. That's my x-axis. And my y-axis is a little bit strange. I have some pretty big numbers here. 150 million, 180 million. So I'm going to make my y-axis, I'm going to make it in terms of units of 50 million. So I have 50 million here, 100 million, 150, 200. So now I have an x and a y-axis. I can get rid of my quadrant 1. There we go. Well, I'm thinking about this and plotting it. In 1950, I had 152 million people, thereabouts, so I'm going to have a point right there. And in 1960, I had 180 million people, so I'm going to have a point about right there. And they're telling me that it's linear, so I'm going to have a graph that's going to look something like that, a pretty low slope, because my y-axis is so condensed. But this point right here has the coordinates 1950, 1,052. And the other point has the coordinates 1960, 1,867. Now, it did say that t is equal to 0, so I could have set, instead of 1950, I could have had that as 0, and I could have had this as 10. Either way, it won't make much difference, because I'm trying to calculate a linear model. I have 2 points. In fact, I even have a y-intercept. But if I want to find my slope, I'm going to follow the same procedure that I always follow. I'm going to take y2 minus y1. So I'm going to have, that's going to be a big number, but we'll try it. 180, 671, 158 minus 152, 271, 417 divided by, if I had 1960 minus 1950, that's going to equal 10, as will 10 minus 0 equal 10. So let's see, do I have a calculator? I have to get my calculator. And I'm going to do this division on the calculator where you can't see it. But if I have 180,671,158 minus 152,271,417, that gives me a slope. So m is equal to, well, I'm sorry, m is equal to 283,99741 divided by 10. So if I put, I'd make this a decimal point, so it's almost insignificant, and I put a comma there and a comma there, get rid of my 10. Now I know what my slope is, I know what my y-intercept is, because it's at the 0 point, this is my y-intercept. So my formula is y equals 2,839,974t plus 152,271,417. And that should be the answer to this part of the problem.